Alright, speedrun continues. The speedrun to AI. I tried to describe today's goal in words. I don't know if they came out all too well. AI packages is a name for little text files actually, like this one. Because once we make the AI do something, we want to make sure it stays able to do the same thing even as the AI evolves. So I suggest we make little concrete descriptions of dialogues, sort of like a little IQ test for the AI here, right? Given a fact and a question, we expect one of these answers. There might be advertising for my project in here, but on the literal level, this means the animal, of course. So we have this test case here, and optionally we can have solutions also, which use the logic engine's constructs, which is facts, which are just sentences, and rules, which have arrows and ampersands and variables, either with a $sign or just short uppercase letters. And this means that maybe we need to help the parser a little bit. The parser needs to know how to group parts of a sentence sometimes. So I threw that in there. This as is cannot be used by the machine yet, but that's what I want to code today. I shouldn't be using this text editor, I should be using my own text editor. For example here. And the windows can be arranged easier too. Okay, first step. Parse. So first we take these underlined sections and extract them. And I just made a function for it, which is called underlined heading sections. And it gives us the two parts of the text as a Java map. And now I'm so exhausted, I need to fill up with iced tea. Okay, we have these two parts, and then we check for these colon separated fields. Yeah, let's make it an actual snippet. Put the input up here. Save as AI packages. Spike. Spikes are little experiments in agile programming lingo. You could say experiment too, I'm sure. Spike. Oh. Activate and test. Good start. Null pointer exception. Interesting, it's in the parsing function itself. Probably we need to unindent actually. No, we don't. Actually, it should work like this. How did I manage to make this exception? Where is my transpilation? Transpile, show transpilation. Yeah. Now I don't have line numbers. What was the line number? This should be automated. Maybe I did it somewhere. Line number is 732. It says this. Oh, that's just an old version of the function with a bug. Just need the latest versions. I think this might be better now. Yes, it is. Test and example solution. Good. Next step. Section, content. Need more space here. Yeah, like this. Aha. Almost, but we only get one of the A and one of the rule entries because it's not a multi-map. How about this? Oops. Okay, now we have all the entries as some pairs. And yeah, we want to pipe it through the logic engine. Feed to logic engine. This up here plus these down here and see if that solves the test. You know, yeah, why not? Test text, and we have example solution text. Text pairs, no, test pairs, and some solution pairs. Let's shorten this a bit. And then we make a philosophy, but oh, I spelled it correctly this time. I learned how to spell philosophy. I can spell properly now.
I can spell properly now.
It should repeat things with reversing the I and U. Let's do that. I want that. Repeat every speech input, but we are changing it. Oh, actually not this duplicate. First the source code, and then here it's a nice and short module. Anything to shorten even more? Nope, I don't think so. It's called switcheroo, a function that switches first and second person. Yeah, actually. Oh, now I introduced a bug because this one. Yes, this should work. Save as switcheroo. Let's try. I am so smart.
You are so smart. I am so smart.
I had to disable one of these.
You had to disable one of these.
I love this function.
You love this function.
This function loves me.
Dysfunction loves you.
Thank you.
Thank me. No problem.
Okay. That was nice. Little effort, big result. We should do that more often.
We should do that more often.
Okay, it keeps we as we. Because it doesn't know, it's not clear if I meant me or me and someone else, or me and the robot, or whatever. One more. You are my robot.
I am your robot.
Smart boy. So we put a program into the bots. And we do the usual, which is just run it. And it will usually print its facts. Yeah, print the derived facts. Okay, what's the program? The program is basically joining all this stuff together. All the facts and all... Yeah. Let's convert this to a multimap, which is easier to work with. Case insensitive as always. And we could make a function out of it. Yeah, let's take the time. I don't have it here. So let's do it. Parse colon property multimap. Well, case insensitive multimap, of course. Multimap. just a simple conversion. And it failed. Oh yes, it's called pairs to, yes. I have long function names sometimes, but this name is global in my language JavaX, which means you don't have to import anything, you just use this function name somewhere. And it was an attempt to make the name as short as possible while conveying all the relevant information. What type it is, the subtype, which is case insensitive, what it parses. It's not the right name, I think. You really get used to not importing anything, just writing function names. It's kind of elegant. Okay, there's some bracketing error. There's also big error. This doesn't even compile, of course. Okay, join with empty lines. And we get all the facts. We concat things, concat lists. We get the facts and we get question or questions. And then we get pairs, or the example solution also all the facts, and we get all the rules. This grouping we ignore for a second. Yeah, let's see what happens. Nothing happens. More brackets here. Oh, I even get the message here, bad hygiene. I'm just too lazy to read the messages. This here. Got him. Here you can see my server down here, the green bar. Each server I have has a bar, and this is the CPU load, so when I transpile on the server, I get a little bar here. Okay, we are close. A gazelle is not slow is already a derived fact from the rules in the input fact. That's good. Somehow it doesn't answer the question, and I think this is precisely because of this here. This grouping issue. Let's see what else is derived. Fast is not. Let's print the program. Let's print the program. Down here, what's happening? Oh yeah, various colored graphs. Servers are doing stuff. Is a gazelle slow? Question mark. Yes, this is it does need the grouping. I think this top-down parser that does the grouping is not integrated in the logic engine, actually. However, I did that somewhere. Solving the Winograd challenge, that's where it was. I should rewatch my video to see how that was done. Okay, there's the parser here. Winograd solver. There's some code. Yeah, this does both. This runs the logic engine, the philosophy bot. And first it does the parsing. So we really need to combine these two things. Have I done that anywhere else yet? Nope. Yeah, this is that was a good video, multiple videos I think, where I solved these actual challenges. Bob paid for Charlie's college education. He is very generous. Who is generous? I solved things like this one with very few rules and patterns. So we should put this thing here into a function or class. Parse first, then run logic engine. Okay. Let's just try the parser on the input. What's the input? Is a gazelle slow question mark. No results. But there's two ways to go about it. Either we go bottom up, which means we take a gazelle and merge this. So we end up with this. Or we go top down and say what kind of pattern is this? And yeah, I mean, because in these rules there is already a pattern visible. Is something something. This is a pattern. And if we have this pattern, we can find out that this is a unit. Yeah, top down will also work. And we would actually not need this int. To group a gazelle together. This grouping and ungrouping of sentence parts is very crucial for the logic engine. Because sometimes you want to treat a part of the sentence as a whole, not look inside of it, pass it around as it is. The man I saw yesterday is just one chunk. The whole phrase, you just move it around, keep it as is. Or you want to look inside. See what it actually says and which parts it has. So you will go back and forth depending on what the rules want. And this has to be automatic for the rule engine to work flawlessly. Hey, now we're in hardcore AI coding territory. Yay. Yeah. You can tell the parser to use certain patterns, or you can tell it to use the patterns that are currently in this session in this module here. So there's like a random list of patterns that are recently used or whatever. And you can use those, or you use your own patterns. Let's use our own patterns. And let's turn this into a usable function. Groupings to use patterns. Or, And this whole code is pretty good because it also notices which rules it used in the process. This is pretty cool. This should be a class of its own. It's maybe easier than to extract parts of this and whatever. Let's try the module again. When it went solver here. Click on solve and it does the job. Yeah, and it's using all the patterns we had in this session, which is too much, but it finds out which patterns it actually needed. This is the cool part. It finds out the answer, and these things are what it used to make this answer. This was what was actually significant in making the answer. It's a fact, this is a rule, another rule, and this is the input plus brackets. Groupings with patterns. Grouping and patterns. What is this? Oh, it's just a short version of a pair. Got it. Okay. Top-down parse to groupings. And it was what? It was a pair of a string and a set. Input and patterns. Make the parser. This was for multiple sentences. Right now we just do one sentence, I guess. Now it's converting to a map. Why do we have what? Not 100% sure what exactly I'm doing right now. Let's check it out. I'm doing bad brackets is what I'm doing. Okay. Give me an eval window. Is a gazelle slow? And the pattern is asterisk asterisk. Oh, we need then a list. Aha. We have 3 entries. Okay. Some of these are nonsensical, but that's actually okay. So this here, which doesn't really make sense, it will just not go anywhere. You can dump it into the engine, and if it doesn't match with anything, it doesn't hurt. This is the good one, and this is the original. So it's totally okay to have some wrong parses. Either it leads to a joke, or it leads to nothing, so no problem. Okay, we get the grouped result, and we get the patterns that were used. Let's simplify this. First, the full version with used patterns, which tells you which patterns were actually used. And then we make the shorter version, which just gives us the parsed things. Nope. Just forward. Okay, so that's much simpler to use. Yes, only the 3 groupings. Very good. And yeah, we just throw all of these grouped inputs into our logic engine. What are our grouped inputs? Oh, all of these actually. Okay, I got it. We need these. And probably we want to group the facts here also. Okay, we have lots of facts. And then we parse all of these. Oh, we need to get our patterns from these rules here, okay. Unparsed facts. get patterns from rules. Grouped facts. Pattern from rule. Pattern from rule. Oh, that's old, I think. NL logic. That's a very old logic engine. Yep, I made many iterations of logic engines. Here, this is a newer one. Okay, yes, we replaced all the variables with asterisks. Yeah. In fact, we could do this outside of the logic engine. Yeah, there should be a way. Yeah. Parse here. Nope. House rule. Yep. I do have to parse this first, I think. Parse programs. Things like this. Now we have the patterns. We can keep the same bot and add more stuff to it. Load program. Load program. group facts according to patterns. Add to bot and calculate. All right. Caps lock was activated, but I fixed it. Four problems. I guess we can deal with those. First one solved. No. Not solved. Why not? Why not? Because it lacks the signature. A function from this to this. This is a type parameter. We get a set of strings. And maybe like this. No. This returns a collection. Two problems, that's better. And I just forgot a little number, which is 1. Philosophy bot 1. Okay. Bot.parse is actually bot parse program. One more problem. Oh. What have we got? Let's print the patterns. Do we have the pattern we wanted? I think I see what the problem might be. No. Oh, but oh, it has not recognized the X, Y, and Z. X, Y, Z. Yeah, there's a special list here that these are variables. Yeah, is variable. We should use that. Fact. $vars to stars. Arbitrary arbitrary vars to stars. Yes, I see what the problem is. Yeah, let's, okay. There. Var set. So we use exactly the variables that the current logic engine knows. You can define new variable names, so to make your rule-making life easier. Set predicate set. Yes. Set. All right. It's a pseudo set that you can only ask for containment. You cannot ask it to list everything, because everything with a $sign in front is a variable. So you can't list all of those. Fail. Try again. Okay, is star star question mark. That's good. Yeah. Oh, in fact, yeah, is a gazelle slow? This is grouping we want. Yeah. It's almost there. Slow. it needs to do one more step of grouping or ungrouping, actually. Then it should do it. So yeah. It's not bad to go for the bottom-up version. A something or not, this kind of grouping. Because where does it fail? Yeah, it fails in the last step. The fact we have is a gazelle is not slow. Here. But this here has X here. And these are 2 words, so we need like brackets around this here. And we could have these brackets. Let's go back to the patterns. Is not This pattern here should be sufficient to group this one. Oh yeah, we need to do this grouping within the logic engine. Yeah. Okay, I think I have a... what's the time here? Not even an hour. Okay, extra logic operations. We can... What am I doing? Printing? No. What am I doing? Add extra logic operation. There. No. We want to do something on every fact. Any code on facts here. On any, yes. Here. Add code on fact. Yep. Like preprocessors? No. This is okay. Okay. Uh-huh. Okay, yes. Add code on fact. Make bot group all facts. Do we have add facts or something? Do. Yes. We don't need this because it's being done automatically in every step. Hmm. Hmm. Okay. Okay. There it is. No, it's a bit buried in all the facts that it made. You want to have it stand out more, I guess. But somewhere along these facts that were made, there's also the answer to the question. Is a gazelle slow? Nope. And so let's add this here, which says which answers we don't like. And yeah, that's pretty good. Check. Check answer. Um, we have the answers here. How about that? We drop all the punctuation and just look at the actual text. Wanted answers. And we say unwanted answers. Let's print those. Hey, this is working. Cool. Slow is not a gazelle. Which is funny, it's of course not the proper rule application, but it doesn't really matter. It's not wrong, it's not breaking anything. Wanted answers. Where's my unwanted answer? Oh, I didn't put it in the program. This here is not the program, this is the program. Also, we got rid of this here. Oh, and we need to reset this field. Here. Hey. Stay here. Okay, unwanted answers, yes, and then we say deduced facts. Set intersect. Yeah. This, what, tiny brain? Oh. Oh, there was still a link to my old domain here somewhere? Where is it? Somewhere there was a link to my old domain. That doesn't exist anymore. The name Tiny Brain got too small for my purposes. List and set intersect. Yes, that's what we want. It's good if we have a wanted answer, and it's bad if we have an unwanted answer. Okay. Bad answer. No answer. Got him. Let me guess, it's called facts deduced, not deduced facts. Well, you know what? I'm going to add the other version too. Because it almost doesn't cost anything in the grand scale of things. On a gigahertz and gigabyte machine, this extra function name doesn't cost anything. Okay, we have it, yes. So this little case is actually solved, that's pretty good. An interesting question would be if all the rules were actually used. And I did have this function in the Winograd challenge stuff. Yeah, with trails and stuff. And then we do this procedure to see what was actually used. Looks a bit complicated. Add simplifier. That's too complicated for this moment right now. How's our code looking? It's not long, is it? Almost one screen full. It's not doing that much. But yeah, okay. So this little AI package is working. So yeah, we have to make more of these. Let's do one more maybe. There are no guest accounts. Do we have any guest accounts? It's like for a smart home where you can have guests. They are known to the system. No. Not an answer, yes. So do we have X? And there are no X, then the answer is no. And this should be the only rule necessary here. We can actually test this, let's do it. First we rename. And we can almost can almost set it in here, but it will give us an input field with only one line. And we need multiple lines, so oh gee. Input, and yeah, this is how the input looks. What if I paste it in here? It's gonna be crap, right? Exactly, no answer. Let's do that quickly. Field menu. String field menu item. Ugh. Now I'm annoyed right now. I want to do that simpler. 790. Just give me a random eval window. Yeah, like this one. Set field. Input. Here. Yeah, this is almost working. Do we have any guest accounts? And what do I match? I match guest accounts without the any. So the engine is very sensitive to that. But we have a global simplifier. Hold on. Rule. Add simplifier. Any. One. Does the simplifier work? Okay, first of all, there's a bad character here. Then we say reload on field change. So we don't have to press reload all the time. Do we have any guest accounts? Yeah, this is not working yet. We have to do this here. Then it will work. I believe. Too many windows, as always. Still no answer. Huh. Ah, there's a pattern missing. We got this pattern here, but this second part, that pattern we do not have, and that's just basically a little bug. Let's do that one. Gather all left-hand sides. Yes, and without. Left-hand side can be a string, or it's of the type and. Or There's something with the structure. You can just go into the structure. Transformable. Yeah, no. All parts of left hand side. This is so boring, but it's another. Just one of the things I have to do. Collect, blah. Oh. Return here. If it's an and, we descend. This actually. And this part, and bada boom. You caught this error too, right? I'm sure. Okay. Okay, where am I using this? This reference. Oh, Vector is snoring. Vector's asleep. And I want to do serious work. I put my robot to sleep. Still no answer, still the one pattern. What's happening? Oh, okay. Why is it not finding this other pattern? This is stupid. Yep, I should have a break soon. So let's fix this last bug and then... Okay. Okay. Oh, the rule has been rewritten from this ampersand on the left-hand side to condition, arrow, boom. Yeah. If this is another logic rule. Mm-hmm. Mm-hmm. Aha, okay. Do we have it? Nope. Ah, now I'm hungry too. I hope I can fix this bug in a second and then call it a day. Yeah. Yeah, okay, I got it. Okay, if it's a logic rule, la la la, collect the left-hand side, and the right-hand side also if it is another logic rule. Otherwise we don't do that, and we do this, and we do that, and then failed, okay. Yep. As I said, I'm getting hungry and stuff. Still fails, oh man. Okay. There it is. are no guest accounts. Do we have any guest accounts? Nope. And if we do something else, it should give no answer, which is correct. Only if these two match, then we have an answer. Oh, and only one rule. Isn't that good? Short programs. And you will see how in general this rule is. Nothing about guest accounts, just a little bit of English dialogue here. Okay, that's it for now. You can see how, programming has two parts. Having a grand idea, and then all the implementation with all the little structures and all the accounting and this and that. So the really detailed process. But we're making something big here, right? It's like nuclear fusion. It's just something complicated that hasn't been done before. But it sounds very appealing in theory. Stay tuned and stay healthy.